Modern data center workloads have evolved. Virtualization and containers now handle almost all computation. Monolithic databases have evolved into massive scale-out NoSQL clusters. Artificial intelligence drives advances in healthcare, finance, and more. All of these uses are enabled by data. Let's see how NVMe can accelerate that data for these three modern workloads. Virtualization and containers are powered by hyperconverged infrastructure, or HCI for short. HCI uses local server storage, often hard drive-based, to build highly available data stores. While hard drives economically store terabytes of data, they alone can't meet the performance needs of advanced clusters. Vendor-supplied in-box NVMe SSD caching can help meet those needs. SSDs in each server can cache data at high speed, removing the hard drive performance bottleneck. NVMe's direct PCIe connection minimizes latency and sustains high bandwidth. For the most demanding HCI workloads, such as business intelligence, a fully NVMe-based storage system helps to meet aggressive SLAs. NoSQL's shared nothing architecture is an ideal place to use NVMe SSDs to maximize server density and ensure performance for demanding workloads. NVMe provides the bandwidth of many individual hard drives, yet only requires the physical space of a single add-in card or 2.5-inch drive. By replacing large hard drive arrays with much smaller NVMe SSDs, you can shrink individual NoSQL nodes and maximize nodes per rack. Garbage collection, a common NoSQL background process, is I/O intensive, can occur at random, and wreaks havoc on NoSQL response times. Especially suited for the many small I/O operations required for garbage collection, NVMe's up to 65,000 command queues and up to 256 interrupts can keep those background I/Os from impacting foreground performance. Training neural nets requires running gigabytes of input data through massively parallel accelerators, which are expensive to acquire and run, so it's essential to keep them fed with data. Most training today uses multiple accelerators connected to a single CPU that feeds the data, but if CPU has to wait for data from storage, the accelerators have to wait too. NVMe's direct PCIe interface, the same interface those accelerators speak, can minimize wasted training time. With no controller chip between the data and CPU, requests for data incur minimum latency. Thanks to NVMe's advanced data transfer features, such as scatter-gather lists that minimize CPU intervention, NVMe can keep CPU overhead to a minimum, freeing the CPU to ensure all accelerators are served data in a timely manner. Workloads in the modern data center are driven by data. NVMe can help to ensure that data is processed more quickly and efficiently than other interface technologies. With its low latency, direct PCIe connection, and massive bandwidth, NVMe is the right choice for these workloads today and in the future.